Hello dear students, how are you? I hope you are enjoying my online classes and your preparation for your term 1 exam is going really good. As you know that term 1 syllabus for physics for class 9 is chapter 8 and 9, and in last 2 week lectures we revised the chapter 8 and 9, and in this lecture before your term 1 exam we will be taking couple of class tests using same online method on Aristotle app. You can give the exam, and before starting of that test series from your term 1 syllabus, that is chapter 8 and 9, this week we are going to have only one video lecture because Monday's lecture is off, and this lecture is for Tuesday. So in this one lecture I am going to give you a quick revision of chapter 8 and 9, telling you the important points, and then you can give a couple of tests before your term 1. So starting from the points, the concept of motion and rest. So rest and motion are relative. Nothing can be said to be in absolute motion or in absolute rest. Things are always in motion and rest with respect to some observer. Without the observer in reference point, motion and rest have no significance. Then we are having uniform versus non-uniform motion. If object covers equal intervals of time in equal time, motion is said to be uniform motion. If object covers unequal distances in equal intervals of time, it is said to be non-uniform motion. In uniform motion, our acceleration is always zero as velocity is constant. So most of students do this mistake. They consider acceleration constant in uniform motion, but that is not the case. And in non-uniform motion, your acceleration is non-zero. It may be increasing or decreasing. The third important point is differences between distance and displacement. So your distance is scalar quantity and displacement is vector quantity. Distance is the actual path covered by the object when it is moving in any direction or following any path, while displacement is the shortest path between initial and final point. So if you are starting from point A and you are going like this and you are reaching on point B, then the actual path covered is going to be the distance, while the straight line shortest path between A and B point, let us say ये आपका B point है इधर, तो the shortest distance straight line path between A and B is known as displacement. AB is displacement and the actual path covered is displacement. In the same manner, if we are dividing distance by time, we will be getting speed, and if we are dividing displacement by time, we will be getting velocity. So that is the concept of speed and velocity. Speed is the scalar quantity and velocity is the vector quantity, because velocity is the displacement divided by time and speed is the distance divided by time. I hope this point is clear. Fifth point, we are having about average velocity, and numerical of average velocity is very important. Fifth point, here we are having average velocity. Average velocity is defined as total displacement divided by total time. And in the same manner, if you want to calculate average speed, then divide total distance by time. तो velocity की जगह अगर speed आएगा तो displacement की जगह distance आ जाएगा, ठीक है? अच्छा, इसमें जैसे मैंने आपसे पहले लेक्चर्स में भी डिस्कस किया, एवरेज वेलोसिटी या एवरेज स्पीड वाले में हमारे पास दो टाइप के न्यूमेरिकल गिवन होते हैं. एक न्यूमेरिकल हमारे पास गिवन होता है जिसमें हमारे को दो डिस्टेंस गिवन होते हैं, से x1 डिस्टेंस and x2 डिस्टेंस A से B और B से C, और हमें इन दो डिस्टेंसेस के बीच में v1 और v2 वेलोसिटी गिवन होती है। तो जब हम अपना फॉर्मूला अप्लाई करेंगे तो कैसे अप्लाई करेंगे, टोटल डिस्टेंस हमें डिस्प्लेसमेंट हमें कैलकुलेट करने की जरूरत नहीं है एवरेज वेलोसिटी के लिए, बिकॉज वो हमें डिस्टेंस गिवन है। तो x1 प्लस x2 हमारा टोटल डिस्प्लेसमेंट हो जाएगा, और टोटल टाइम कैलकुलेट करने के लिए हमें इंडिविजुअल ए बी और बी सी पे कैलकुलेट करना पड़ेगा। हमारे पास डिस्प्लेसमेंट है, वेलोसिटी है, तो जो टाइम t1 हमारे पास ये लगेगा और यहाँ पे टाइम t2, तो t1 जो होएगा वो होएगा हमारा डिस्प्लेसमेंट बाय वेलोसिटी x1 बाय v1 प्लस x2 बाय v2। सो यूजिंग दिस वी कैन ऑलवेज कैलकुलेट एवरेज वेलोसिटी इन द केस व्हेन different velocities are given for different distances. The second case here is like for different time intervals. Say v1 velocity is there for t1 time and v2 velocity is there for t2 time. Now velocity and time are given. Please go through this video again and again. The first case is for two different distances if two different velocities are given, and second case is when for two different times two velocities are given. So now we have to calculate the displacement, because in A to B and B to C, so A to B displacement is going to be v1 into t1, let us say that is x1, and for B to C velocity into time, v2 into t2 is equal to x2. So total formula is same, total displacement by total time. So your average velocity is going to be total distance, that is v1 t1 plus v2 t2, or divide by total time, that is t1 plus t2. So take care of this thing, and meanwhile you have also take care of units. So in Zoom classes some students were getting confused between how to convert from mile per hour to meter per second, or from kilometer per hour to meter per second. So let me tell you how to convert velocity into different units. If you are having any speed in kilometer per hour, say 36 kilometer per hour, and you want to convert it into meter per second, always remember from kilometer per hour to meter per second you multiply by 5 by 18. 18 to the 36, so you will get 10 meter per second. And whenever you are having kilometer per hour, say whenever you are having mile per hour, say 10 mile per hour. So mile per hour is also written as sometimes mph, that is miles per hour. So you must remember that 1 mile is equal to 1.6 kilometer. So first you can convert from mile per hour to kilometer per hour by multiplying by 1.6. So 10 mile per hour, when you multiply by 1.6 you will get 16 kilometer per hour. So remember this, for converting from mile per hour to kilometer per hour you multiply by 1.6, and once you have it in kilometer per hour you already know that by multiplying with 5 by 18 you will get your answer in meter per second. I hope the point is clear. 2 8 is 16 and 2 9 is 18, so 40 by 9 meter per second from 10 mile per hour. Okay, and one more important point was there. Sometimes acceleration, whose unit is meter per second square or kilometer per hour square. Sometimes acceleration is not given in kilometer per hour square, but acceleration is given like kilometer per hour per second, kilometer per hour per second. So students are getting confused in this. So let me clear you one thing, that kilometer per hour is the unit of velocity which is divided by unit of time. So for calculation of time it is not mandatory that you must express your acceleration in kilometer per hour square. For example, the question with the plane which needs to cross the sound barrier. Suppose the speed of the plane is changing from 500 kilometer per hour to actually the statement was from 600 kilometer per hour to 1200 kilometer per hour in how much time? If acceleration given is 100 kilometer per hour per second. So this statement is simply indicating that 100 kilometer per hour speed is changing every second. So you can calculate how much change in speed is required. For 600 to 1200 kilometer per hour, change in velocity is required v minus u, that is 1200 minus 600. So it is 600 kilometer per hour, that is your v minus u, and we know that acceleration is equal to v minus u divided by time. So 600 kilometer per hour divided by time in seconds. You can put the value of acceleration kilometer per hour per second as given, 100 kilometer per hour per second. So if it is given like this per second, you can directly calculate time in seconds without converting it from kilometer per hour to kilometer per hour square. So your value of t will be 600 divided by 100, that is 6 seconds. Also, if you will look at it with simple concept, the change in speed is taking place at the rate 100 km per hour per second. So 100 km per hour speed change हुई है 1 सेकंड में. तो by unitary method if you will go, so if 100 km per hour is changing in 1 second, then 600 km will change in 6 seconds. So it is just for checking your concept. Okay. Moving forward, we are having equations of motion, and as we discussed, we can derive the relation for equations of motion by calculating the area of the velocity time graph. If you are having velocity time graph, and let us say this is the final velocity, this is the initial velocity, and this is the time taken, then we are having this area divided into two parts. One is this square and other is this triangle, and area of this graph will give us the displacement. So area of the square is obviously this is u, or rectangle, so ut, which is giving us distance, plus, and the area of triangle is half into base, that is t, into height, this is v minus u into v minus u. So s is equal to ut plus half t into v minus u, and we know that by definition of acceleration, v minus u divided by t is acceleration. If I take t on this side, v minus u, and rewriting v is equal to u plus at. So that is your first equation of motion, and if I put the value of t from this equation, v minus u, the value of v minus u, I can put the value of v minus u is 80 if this t will go and multiply there. So if I put the value of v minus u 80 in my second equation, s is equal to ut plus half t into my v minus u place at v minus u, we can write 80. So it will become s is equal to ut plus half 80 square. So that is your derivation for second equation of motion. And third equation of motion we can derive by applying the area of parallelogram. The formula is half into sum of the sides u plus v into distance between them, and distance between them is t, and in place of t I can write v minus u divided by a. So 2a will come on left hand side in multiplication from division, and a minus b or a plus b will give us the formula a square minus b square. So that is your third equation of motion. Moreover, one more important equation we can have at this point, that is the distance covered in nth second. Some students have asked that question in their own classes also. So if you are having distance covered in n seconds is equal to un plus half an square, that is first equation, and distance covered in Sn minus 1 second is un minus 1 plus half a n minus 1 square. So distance covered say in 5 seconds minus distance covered in 4 seconds will give you distance covered in nth second. So distance covered in nth second is generally represented by dn, or we can also write it like Sn, which means distance covered in nth second, and it is equal to distance covered in nth second in n total seconds minus distance covered in n minus 1 second. So if we will apply this formula, half an square minus u n minus 1 plus half a n minus 1 square. Okay, solving this, we are having un minus u plus a by 2 and a square plus b square minus 2ab, removing the bracket and changing the sign, and we are having minus outside, minus un plus u minus an square by 2 minus a by 2 and plus an. So half an square and half an square cancel, plus un and minus un cancel, and we are left with u minus a by 2 plus an. If I will take u plus half a common, what I will have inside 2n minus 1. So this is my equation for distance covered in nth second, represented by as nth or dn divided by 2. So this is my equation for distance covered in nth second, and you can apply this equation directly for solving many numericals. Okay, so you can go through this derivation and you can apply this formula directly. Moving on to motion chapter, we are having laws of motion, and the first law of motion, Newton's first law of motion, states that if any object is at rest, it will continue to be at rest. If it is in motion, it will continue to be in motion until unless any external force is applied. The definition of force: any external pull or push which changes the state of motion of a body or changes its size or shape or try to do so is known as force. So that is your first law of motion, which is also known as law of inertia. Second law of motion is the real law of motion, Newton's second law of motion. And one more thing, dear students, do not get confused between second law of motion and second equation. Many students in their assignments, homework assignment, they have written second equation of motion in place of second law of motion. So please take care, study your question statement carefully, that whether the examiner is asking about law of motion or the examiner is asking about equation of motion. There is huge difference. So second law of motion in simple words is that F is equal to P2 minus P1 by T, that is rate of change of momentum, and we know that P is equal to mv, the formula of momentum. So P2 is going to be mv if v is the final velocity, and P1 is equal to mu if u is the initial velocity. So I can write mv minus mu divided by t, that is also equation of second law of motion. Taking m common, v minus u divided by t, and we all know that v minus u by t is a, so F is equal to ma. So all these four relations, any relation can be applied for solving the numericals. डिपेंडिंग ऑन आपको क्वेश्चन जो है वो किस में गिवन है, मोमेंटम और टाइम गिवन है, वेलोसिटी मास और टाइम गिवन है, या मास और एक्सेलरेशन गिवन है, तो आप इनमें से कोई भी जो है फॉर्मूला वो यूज कर सकते हैं. एंड द थर्ड लॉ ऑफ मोशन स्टेट्स दैट एवरी एक्शन हैज इक्वल एंड अपोजिट रिएक्शन. So, and we are having so many examples for that. And the last topic is momentum conservation, which says that total momentum of a system remains conserved until unless any external force is applied. So which states that simply if initial momentum is say 0, then final momentum must also be 0 if no external force is applied. This can also be some other constant value. Particular 0 value is for your bullet and gun example, like P1 is equal to 0 before firing of gun, and after firing we know that minus mu, the gun is moving in backward direction, so minus plus small m mass of bullet into v velocity of bullet, this is the final momentum. And P2 must be equal to P1, that is 0, which is our momentum conservation equation. Okay, so mu minus plus mv is equal to 0 gives us capital mu is equal to mv and u is equal to mv by capital M. This is your formula for solving the recoil velocity of gun, where u is representing recoil velocity of gun. So with these words, I would like to wish you all the best for your class tests and your term 1 exams. On Tuesday we will also be having, that is today for you, we'll also be having Zoom live class, and you can ask me your doubts and numerical problems. I will solve in online class. Thanks, see you soon, take care, bye.